Finally, in question 5, we're asked to consider the balanced equation. There's the equation there. And we're told if 5 grams of copper metal is reacted with an excess of nitric acid in accordance with the equation given, what will be the volume of NO formed at 25 degrees Celsius and 108 kilopascals pressure? Well, just to start off with, I'm going to quickly write down the values that were given. Given a mass, let's call it M subscript C for copper, is equal to 5 grams. We're also given a temperature. Well, converting this into an absolute temperature, it's kelvins. We know that temperature in kelvins is equal to 273 plus temperature in degrees, often denoted by theta. And so then we'd have a temperature in kelvins of 298. And we're also given a pressure, let's say little p is equal to 108 kilopascals. So evaluating this question then, the first bit of information we're told is that we have an excess of nitric acid. What does that mean? Well, it means that the copper is the limiting factor. The number of moles of copper is going to determine what we get on the right. We can also, in our heads, we can start to ignore these other factors coming into play now. They're almost just here to confuse us as they're irrelevant. All we've got then here, we can think of it as a ratio. 3 moles of copper can react to make 2 moles of NO. So let's write this down as a bit of a ratio. Then we have, let's say, the number of moles of copper, N sub C, compared to, or the ratio to, number of moles of NO. Let's just put N sub N. We would have 3 there, number of 3 moles, let's say, of copper, or stoichiometric coefficient of 3, and then we have a 2 in front of the NO, 3 to 2. If we divide both sides by 3, as we can then have 1 to 2 over 3. 1 because we could theoretically we can then calculate the number of moles of copper, and if we know how much 1 mole of copper is, we know how many moles of NO we will have. And so that would mean then, how many moles of NO do we have? Well, we have 1 to 2 over 3. For every 1 of 1 copper, 1 mole of copper, we would have 2 over 3 moles of NO. So then we'd have times 2 over 3. Now we know the number of moles, we can just resort to our ideal gas equation, PV equals to nRT. This then we would originally be thinking of the volume of NO and the number of moles of NO, but we've just shown that the number of moles of NO is equal to 2 over 3 times the number of moles of copper. So we can take this a step further to say that pressure times the volume of nitric oxide gas is equal to 2 times the number of moles of copper times by the universal gas constant times temperature over 3. Rearranging to make volume the subject, we can divide through by pressure. Then we'd have 2 NCRT over 3P. And finally, we can just substitute in our values. We'd have 2 times, well, the number of moles of copper. We know that number of moles is mass over molar mass. That'd be 5 over the molar mass of copper, which is actually 63.5. And that'd be times by the universal gas constant, 8.31, times by the temperature, the absolute temperature, 298. And all of that would be divided by 3P. And P, the pressure, 3 times 108. And if you were to do that on a calculator, you'd get a value of 1.20 litres, and that's been quoted to 3 significant figures. Litres, because we've been dealing with kilopascals. If this was just in pascals, this would be in millilitres. Litres is the same as decimeters cubed. If this was in pascals, then we'd have an answer of centimeters cubed.